Hello friends, I Prof.Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head Control System Engineering. So friends, as far as our today's session is concerned, so we will try to learn the two important parameters of this control system. As you can see, their names are nothing but what? The controllability and the observability of that system is at what point that system or that given control system is being called it is as a controllable system, and at what point that given control system is being called it is as an observable system, that we need to determine with the help of this numerical. So as you can see, in this numerical we used to have the state equations with us denoted as a x and y. So basically x is nothing but what? Input state equation, and y stands for what? The output state equation. So before going to determine the coefficients of this either controllability matrix and the observability matrix, first of all we need to understand that whenever we are able to convert the initial state of that control system into the final state by the application of certain control input which is to be applied over a certain interval of time, at that time that given control system can be called it is as a controllable system, right? This is the basic definition of this controllability, and in order to decide the controllability of this given control system, we need to declare one control matrix. Their coefficients are nothing but what? This b followed by ab followed by a square of b up to this will get iterated up to a to the power n minus 1 times of b, right? So within these two parentheses, all these are nothing but what? The adjacent matrix which are to be obtained from the given system equation. So as far as this given system equation is concerned, as I told you earlier, this state equation for x is nothing but what? Denoted with this term called it as x dash. So basically it is a first order differentiation of this state equation. Always it is written in this form: x dash equals to ax plus bu, right? So x dash equals to this whole matrix A into x plus b into u, and as far as the output statement is concerned, y equals to what? Cx plus du. Here we don't have this dth term, so y equals to c times of x, right? So first of all, what we need to do? First of all, we need to declare the elements of this matrix capital A, right? Their elements are nothing but what? As you can see, -1, -1, 1 and 0, right? Now another important thing which we need to understand is how many number of terms we need to include within these two parentheses, right? It is decided with the help of this suffix n, where suffix n is nothing but what? The order of that matrix, right? So by looking into this eighth matrix, which consists of 2 rows and 2 columns, right? Means the order of this A matrix is nothing but what? 2 cross of 2, or the order of this A matrix always it is n cross of n. And as far as this capital B is concerned, which consists of 2 rows and 1 column, so its order is always how much? N cross of 1, right? The order of this B is always it is n cross of 1, and the order of A is nothing but what? N cross of n, right? So as we are having 2 rows and 2 columns, so n equals to how much here? 2, right? Now according to the basic definition of this control matrix, it will get iterated up to a to the power n minus 1 times of b, right? So as we know, n equals to how much? 2. So a to the power 2 minus 1 times of b, and the first term will be what? B, right? So it will become b into ab. So these two terms we need to include within these two parentheses, right? As n equals to 2, so a to the power 2 minus 1 times of b, and the first matrix or associated matrix which we need to consider is nothing but what? Capital B, whose order is nothing but n cross of 1, right? So accordingly, here what we need to do, initially we need to determine this associative matrix, that is nothing but what, A times of B, right? So as you can see, this is the identical matrix belongs to A as far as B is concerned. So the elements are nothing but what, 1 and 0. So what exactly we are doing here, we are supposed to determine this associate matrix, that is nothing but what, A into B or A times of B, right? So here I will write the desired coefficients of this A times of B. Then after that what we need to do, simply we need to follow the rules for matrix multiplication, element by element multiplication. So this first row will get multiplied with this column, right? So as a result of this, minus 1 times of 1 plus minus 1 times of 0, so obviously it will become minus of 1, right? As far as the second row is concerned, first element is nothing but what, 1, so 1 into 1 plus 0, so obviously it will become 1. So see, this is nothing but what, the matrix denoted as A times of B, right? In order to decide the controllability matrix, we are in need of these two terms, this B and AB, right? Now AB already it is being tabulated, that is nothing but what, minus 1 and 1. What about this B? It was mentioned within that given state equation, AX plus B times of U. So B consists of 2 rows and 1 column, so their elements are nothing but what, 1, 0, right? So in this way, all the elements belongs to this controllability matrix is to be declared. Then after that what we need to do, then according to the Kalman's rule, we are having one certain condition. That condition tells us that if the modulus of this controllability matrix is not equals to 0, at that time that system can be called it as a controllable system. Otherwise that system can be called it as a non-controllable system, means we are in need of the modulus of this controllability matrix. Now how to determine the modulus? If suppose these are the elements A, B, C, D of this matrix, call it as a B, so its modulus will become what, A times of D minus C times of B, right? So in this way its modulus will become what here, 1 into 1 minus of 0, right? So its modulus is exactly equals to what, 1. As it is not equals to 0, means we can say that this is the controllable system, right? So this is the first part in which the controllability is to be verified of that given control system with the help of these two state equations belongs to input and output. In same manner, in that lateral part, we need to decide the observability of that given control system, right? So first of all, we need to understand at what point that system is being called it as a observable control system. So in this lateral part, we will try to learn how to determine the second important parameter of that control system, whose name is nothing but what, the observability. So just similar to the controllability, first of all we need to understand at what point that system is being called it as a observable system, right? So the answer for that question is nothing but what, when it is possible to determine the initial state of that control system by observing its output at a certain interval of time, at that time that system is being called it as a observable system. And in order to decide the overall observability of that system, similar to the controllability, one matrix we need to define, whose name is nothing but what, QO, and its coefficients are nothing but what, the transpose of this C followed by A transpose into C transpose, then A transpose square into C transpose, up to this will get iterated up to A transpose to the power of n minus 1 into C transpose. Just similar to the way in which the controllability of that given control system is to be tabulated. Here the only difference is what? Here the associate matrix are present in terms of their transpose form. So transpose of C transpose of A, right? And another thing we need to understand is how many number of elements we need to include within this observability matrix. How many coefficients or how many associative matrix we need to include. That depends upon this fellow, that is nothing but what, suffixion. The order of this matrix here clearly as we know from the given state equation, the size of this A matrix is nothing but what, n cross n. It consists of 2 rows and 2 columns, means n equals to what, 1. So this, how many number of times this will get iterated? A transpose to the 2 minus 1 times of C transpose, right? So how many elements we need to include within this matrix, which exactly equals to QO C transpose followed by A transpose into C transpose. These are the two desired terms which we need to include within this observability matrix. So first of all, what we need to do? First of all, we need to decide the transpose of this C matrix. C, it is a part of that output state equation denoted with this Y, right? Y equals to what? Here, as I told you earlier, Y equals to Cx plus du, right? So here, the size of this matrix is nothing but what? It consists of 1 row and 2 column, right? So obviously, its transpose will become what here? The transpose of this C matrix will become, which consists of 2 rows and 1 column. It will become 0 and 1, right? Here A equals to what? A equals to, here I will write minus 1, 1, 0. So obviously, its transpose will become what here? The first row will become first column. So minus 1, second row will become second column, 1 and 0. Then after that, the same methodology is there. We need to multiply these two associative matrix, C transpose and A transpose multiplied by C transpose. So as we are having this C transpose and A transpose, so first of all we need to decide this term, A transpose into C transpose, right? So A transpose equals to what? Minus 1, 1, minus 1, 0. C transpose equals to what? 0 and 1. Then similarly, just exactly similar to the controllability, we need to multiply these two matrix elements. As a result of multiplication, minus 1 times of 0, it will become 0, plus 1 into 1, so first element here it will become 1, right? Second row of this A transpose is nothing but what? Minus 1 and 0, so this will get multiplied along with this addition sign as far as this second adjacent matrix is concerned. So minus 1 times of 0, obviously it will become 0, and 0 times of 1, so it will become 0. So A transpose into C transpose equals to what? 1 and 0, which consists of 2 rows and 1 column as a result of matrix multiplication. What we want? We want this observability matrix, which consists of these two adjacent terms, C transpose and A transpose followed by C transpose, right? So this term is being already tabulated, which consists of 2 rows and 1 column. Now what we need to do? Simply we need to consider this first term, that is nothing but what? C transpose. C transpose equals to what? Which consists of this 0 and 1. So this whole term will become, here I will write this 0, 1 and this 1 and 0, right? This 1 and 0 is nothing but what? It is the multiplication in between A transpose and C transpose as a result of matrix multiplication, which consists of 2 rows and 1 column, right? The first column indicates the elements of this C transpose, which exactly equals to what? 0 and 1. How these elements are to be declared? From the given state equation, C equals to what here? 0 and 1. So its transpose will become what? 0 and 1. This row will get converted into one single column, right? Then one more time we need to determine the modulus of this existing term. If the modulus of this term is not equals to 0, then that system is being called it is as an observable system. Means we can determine the initial state of this given control system, which is denoted with the help of this state equation by observing its output over a certain interval of time, right? So when we determine the modulus of this existing matrix, obviously 0 into 0, it will become 0, minus of 1 times of 1, so it will become minus 1. So modulus of this matrix equals to what? Minus of 1, as it is not equals to 0, whether it is positive or negative, it has nothing to do with that. It should not equals to 0, right? At that time we can say that this system is a observable system. So in this way, these two important parameters, which are nothing but what? The controllability and the observability of that given control system, is to be determined with the help of this control matrix and the observe matrix, that is nothing but what? Q0 and QC. So I just hope that you had understand all these things belongs to this controllability as well as the observability. Thank you.